Hi there. For this video, we are given the problem, what is the remainder when 2x raised to 2015 minus x raised to 2013 minus 4x raised to 2012 is divided by x squared minus 1. So before we answer this, feel free to pause the video so you can try this out on your own. Okay, let's start. So first, take note that when we divide a function by another function, the outcome is, let's use a different letter out here. The outcome is given by q of x plus r of x all over g of x. So what are these functions, or what does these functions represent? Take note that f of x out here represents the dividend. G of x refers to the divisor, while q of x out here represents the quotient, and r of x out here represents the remainder. So in this problem, our goal is to find this remainder out here. So now, let us define what these functions are given these two. So clearly, our dividend is this one out here. So we can write this as 2x raised to 2015 minus x raised to 2013 minus 4x raised to 2012 all over our divisor in this case is x squared minus 1. This is equal to, our quotient is unknown, so we just write q of x out here plus, here's the important part. Take note that since our divisor is of degree 2, then r of x, or our remainder, is either linear or constant. But at most, it is linear. So we may assume it to be of the form ax plus b, wherein a and b are constants. If a is equal to 0, then the remainder becomes b, a constant. So this is the correct form to represent our remainder. So let's write that one down. We have here ax plus b over our divisor, x squared minus 1. Now from here, what I'll do is I'll multiply both sides by x squared minus 1 to remove out these denominators. So we'll have here, let's copy this one down. And this is equal to x squared minus 1 times q of x plus ax plus b. Lastly, take note that x squared minus 1, this is equal to x minus 1 times x plus 1 by difference of two squares. So we'll have here 2x raised to 2015 minus x raised to 2013 minus 4x raised to 2012 equals x minus 1 times x plus 1 times q of x plus ax plus b. So this will be our working equation. Okay, so good. This is what we have so far. And again, our goal is to find this, since this represents the remainder. More specifically, we need to find A and B so that we'll be able to determine the remainder. How do we do this given this equation? Take note that since we don't know q of x, we need to eliminate this from our equation. So how do we do that? Well, we'll be using these two factors out here. Since observe that at x equals 1, this becomes 0. So in turn, we have eliminated this part of the equation. Similarly, if x is equal to -1, this becomes 0, and multiplying that to this part of the equation eliminates it as well. So we'll be using that idea in mind to solve this one. So at x equals 1, we have here 2 times 1 raised to 2015 minus 1 raised to 2013 minus 4 times 1 raised to 2012 equals 1 minus 1 times 1 plus 1 times q of 1 plus a times 1 plus b. So on the left side, since 1 raised to any exponent is just 1, then we have here 2 minus 1 minus 4. And this is equal to, on the right side again, this becomes 0. So this whole part out here just cancels out, and we'll be left with a plus b. Simplifying the left side, we'll have -3 is equal to a plus b. This out here represents our equation 1. Let's put it out. Let's put it just out here. Let's try to observe what happens at x equals -1. So at x equals -1, we'll have 2 times -1 raised to 2015 minus x raised to, x should be -1 raised to 2013 minus 4 times -1 raised to 2012, and this is equal to -1 minus 1 times -1 plus 1 times q of -1 plus a times -1 plus b. On the left side, this simplifies to -1 raised to 2015 will be 2 times -1. -1 raised to 2013 will be -1 minus 4 times -1 raised to 2012 will give us 1, since it's like this. So -1 raised to an odd, if n is odd, then this becomes -1 still. But if it is even, see 2n, then this becomes just 1. So something like that. So this is equal to, again, since this one will be 0, then this whole part out here becomes 0. So we remove that one, and we'll be left with -a plus b. Simplifying the left side of the equation, we'll obtain here, so -2 minus -1, so that's -2 plus 1, that is negative 1, and then minus 4 will give us negative 5 equals negative a plus b. So this out here is our equation 2. There. So now that we have this two equations and we have two unknowns, then we know that by systems of equation, we'll be able to solve this one. So first, what we can do is we can add these two, since we have negative a out here and a out here. So doing that, we have here negative 3 equals a plus b plus negative 5 equals negative a plus b. So negative 3 minus 5 will give us negative 8. Then this out here, cancel, and we'll be left with 2b. Dividing to both sides, and we obtain b equals negative 4. After this, we just plug in negative 4 to either equation 1 or equation 2. So let's try to plug it in equation 1. So we'll have here negative 3 equals a plus negative 4. So what we do is we simply add 4 both sides, and we'll be left with a equals 1. So now that we have a and b, we just plug it in to this form out here. So we have here the remainder is given by 1 times x plus negative 4, or simply x minus 4. This out here is the remainder for the given problem. And that's it. So we have found the remainder when we divide 2x raised to 2015 minus x raised to 2013 minus 4x raised to 2012 by x squared minus 1. So as you can see, we didn't use remainder theorem, or not the typical remainder theorem to be exact. Also, we didn't use long division out here, since if we apply long division, it becomes problematic as these exponents are very large. So I think this is the best way to solve this one. But if you have other solutions or other answers for this one, feel free to comment it down below, as I would also like to learn more on how to solve this and learn more efficient ways to get the remainder for this problem. So that's it. I hope you enjoyed this one. Feel free to comment down below your recommendations and suggestions for future videos on this channel. So that's it, and that is all for this video.